On the screen we have another example, and our objective is to obtain the bond graph model, obtain the state space form, and the transfer functions. So in here we're gonna see, just make sure we understand what the problem is. And the first thing is that we define that there's several loops in here. You see this loop in here? This we're gonna do I1. You have this other loop over here, which is I sub 2. And then you have this one right here, which has I sub 3. Yeah, these are the ones that are in your lab, but we have to watch out. This is an I element between two loops, and usually that may lead to derivative form, but we'll see what happens. So in here we're going to write the one junction for I1, another one junction for I sub 2, you have a one junction for I sub 3, and you see here there is also one, let's call it I sub 4. So on this one, yeah. Now the second step it says to attach the elements that experience the current. So this is obvious. This is an I element with the value, let's call it the, L1, or this has a number, so I'm just gonna put the number as is in here. This is the voltage source with value V, or here like this, and then let's see, we don't have any other inputs. This one experiences the current. This is the C element with value also 1. Okay, so let's begin doing what the elements that act in between the others. So that is going to be this element number, yeah, this one right there is between I1 and I sub 2. So we are gonna say this minus this other current. This one is I1 minus I sub 2, and this difference is what this C is, which is this I element in here. Yeah. Okay. And then we have this other over here. This is 0. We could say this is I sub 2 minus I sub 3. And then we're going to put this element in here, which is this R element. Now in between 1 and 4, we also have this situation. This is going to be element number, this is going to be I1 minus I sub 4. And we have this I element in here. And between I sub 4 and I sub 3, you have also one of these. And this is a 1. And this is going to be C element here, like that. And this is our bond graph model. Just from experience, in here you see you have an I element that basically is on a 0 junction, one that is on an I. Chances are that these are independent. They are dependent on each other. So I'll tell you in a moment, if that happens, how to how to resolve it, okay? So why don't we just go back here, and I'm gonna make it small window like that, so that but we need to have the entire see right there. Yeah, this would be enough for us to do the drawing of the bond graph model here, which is going to be right here. I will put it, yeah, like that, so that I can see it. I'm going to go this one to the left and this one to the right. See, now I have a very good view. And so now I'm going to say this is a new model, and that way gives us the ability to draw this right here. So this is SE, and then we have the 1, and we put it like that. Then we have the 0 over here, and we do this, and then we have the 1. I haven't reduced this bond graph at all, so I still have this intermediate values of, so it just adds more bonds, but it doesn't change the system at all. And then we have in here a 1 like that, and then you have the I element over here. There you go. So far so good. So this is the 0 over here, and then we have to put the 1 over here, and then we have another element, and I expect this would work just as well. And then you have a 1 junction, which is over here, and now we have to put the C element in here. See, whenever you see those red lines, it means the bond graph is not complete, or there is a problem with this causal mark. So in here I'm gonna put this 1 in the middle, and then we have to put the zeros in the middle. So then you have this right here, from here to here, and from here to here, and we have a 1 that is another I element down here. So far so good. And then you have the 0, see, click, 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 and I think this is it. We do have a, oh, we do have a C element. I see. We have a 1 over here, and with this, see, this is not complete, so in here hopefully everything will work out fine. And it did. Wonderful. So that means this bond graph model, we don't see any red signs or messages or anything like that. All the causal marks and the equations are going to be totally normal. You could count the number of equations that you're going to get, because you have the number of i's and c's in integral form, which is 1 and 2 and 3 and 4 and 5. You're going to have 5 equations here. So I will go, before I I do anything else, I want to save this bone graft model, so I am gonna go and click over here and let's get a picture of it. Yeah, right there. And that picture, we're gonna save it in our notes that we're building right here. Okay, so we're going to do that right here. Okay, very good. This is important because with this I can refer to the MATLAB file and not be with the number. So do you see the output in here? This is the output, and the output is V11. In other words, the voltage across the C element. So the that's what that is. So in here the output for this particular voltage of C, which is E11, is my transfer function. So we could keep it at one transfer function as the problem indicates, or we could arbitrarily choose another one. Like for example, I could say what's the current isophore, and if I do the F16 would be isophore, or F13 also. But right here I could just say isophore and is equal to F16. So those two are my outputs. So okay, having done that, I'm gonna go to the MATLAB over here, and then you say okay. As you can see, the CampG software will produce without much of a trouble the equations, whether the system is in this case 2 or 5 equations, it does it with the basically the same accuracy. So I need to define the outputs in the program. What did I say they were? I just had a moment ago. E11 and F12. So let's go over here and say find for me where E11 is. Okay, E11, and it was F16 was the other one, right? So there we go. E11, this is like this, and then we're gonna do this number 2 like that, and this is going to be 2, and then it's gonna be 2. Now what am I saying? This is 1. 1. This is row 1, and then we need to define for F16, this is going to be the 2. F16 like that. We activate the 3 lines to be able to tell the computer that this is output number 2, and then we form the matrix number 2 in here. And I think we're ready to go. The only thing is, just comment this one. And then we go. Click in here. I did something here. Line 43. I might have deleted accidentally something that really didn't mean it. Huh?
You need to give values to this. You're not an SYM.
Yeah, that's the problem. You're catching up.
Oh, we are here. But we did get the, okay, let's try this. There we go. Yeah, so this are the matrices A, B, C, and D. All right. When you get this, it means that we didn't do the, I see what happens. We need to put the numbers in here to be able to get what we want. And I didn't do that. So we have a option here to go back and put the numbers in here, or to redefine this. I think we could try this. We just go put the numbers in here. The program gave us numbers, right? Or not? Yeah, it did. You see, all of them are 1. Yeah?
Yeah.
So why don't we do that thing here? Just put, yeah. In other words, we're doing the CamG num. The reason it gave me that error is because for that file you need to have the numbers instead of operating with symbols, and that's what we're doing right now. So you could do with CamG SYM or with CamG num, but if you do num, make sure that you put the numbers. That's why you didn't like it. So we're gonna go and say run this and get out over here. There it is. We just run it with the numbers. Okay, hold on a second. The computer's still running here. Okay. Here we go. And then we have the transfer functions. Because we have 2 outputs, we're going to get each output with respect to an input. And that's what the transfer function here is. So we have obtained the state space form, as you can see here, the matrices, B and the C and the D, the characteristic polynomial, the 2 transfer functions that we needed, and then of course with these ones we can go and test with different functions in there. But these are the transfer functions.